Tonicity is a term that we use to refer to whether a solution is going to cause a cell to either gain water or lose water. And this is very much affected by the solute concentration. And so this is because what we're looking at here is really osmosis. And osmosis, the direction of water movement down is concentration gradient, that is affected by the solute concentration. So if we look at the three example cells that we have right here, they all have a different internal solution concentration, so that's concentration of solutes, and that's in comparison to the surrounding solution. And so if we look at the middle one first, notice that this one has inside of it approximately the same solute concentration as we have on the outside. So inside we see the same solute concentration compared to out here, and it's a relative concentration. And so this is what we refer to as an isotonic solution. And again, isotonic is referring to the solution on the outside itself. But the word iso, that prefix there, it means same. And when you have the same solute concentration in both compartments, you are going to have the same free water. So by free water, we're talking about unbound water concentration on both sides. So that would be inside and then outside. And so what that means is that some water is going to come in and some water is going to go out. But what it boils down to is that there's no net change in the direction of water movement or in the cell's water volume. So the cell's not gaining water, it's not losing water. If we look at the other two, notice that this one over here, if we compare inside to what we have outside, we have much more solute. So there's more solute or a higher concentration on the outside compared to what we have on the inside. So on the inside would be a low solute concentration. And then when we look over here, on the outside is going to be a low solute concentration compared to the inside, which would be a high solute concentration. So if we use terminology for these other solutions, the tonicity refers to that surrounding solution. So this one over here, it's high on the outside, and we refer to that as hypertonic because hyper means high. And then this one over here is what we call the hypotonic because hypo means low. And then if we look at the direction that the water is going to move, we have to consider that the water is going to be affected by the solute concentration. So it's an inverse relationship. Where you have a low solute concentration, we will have a higher free water concentration. And that would be compared to what we have outside. So if in here we have less solute, we're going to have higher free water, but out here we have more solute, so we're going to have lower free water. And the reason for that is that the solute is going to be bound up, binding up the water molecules. So water goes high to low, so the water is going to be moving out, which means in this particular example, the cell loses water. So it's going to shrink up and get smaller. And then this one over here, again, it's an inverse relationship. So inside, if we have high solute, we have low free water concentration. And that would be compared to outside, where we have a low solute concentration, so we have higher free water. And again, water moves high to low. So we look at where the water is high and where it's low, and in this case, the water is going to move in. So in this one, the cell gains water, and that means it's going to swell up.